managed to make it work. Unbelievable. I don't know what was happening with those diodes. I tried different permutations and I get good results actually. Right now this counter, I don't know how to show you because I don't have the circuit here. I have the circuit on my phone actually. I cannot show you, but what I did, I will try to explain to you. These two chips are instead of those 4 diodes that were here, and on those diodes I'm using my golden Hercules oscilloscope there. Very extremely good. It's doing almost nothing. But it is good enough, I mean, for checking if it's a high or low, you know. For this only for this reason is good enough, you know, to check if it's high or low, and that's it. And the thing is that I was probing here with my oscilloscope, and I was getting exactly what you are saying here, like it's disconnected, like it's on 0 volts on ground. Right now it's disconnected, it's not connected to anything. So I was probing everything, including this, actually this wire that is the setting wire. If you want, when you set, you know, you have to put this time is only 1 wire, but you have to put 2 wires, 3 wires, a maximum of 4 wires to make all the 16 combinations to count, to create the logic. Right now it's counting to, let's see here, if we are looking here, right now it is connected to, not to A, but to D. A is the white wire here, this is A, pin A, and, well, port A, and port D is connected to this 430, KDB 430, which is a 8-gate and NAND gate, with 8 gates. This is the only output that is having here on the yellow wire. Here is the only output of it, and all of these pins are, some are not connected to anything. Some pins are just nothing, but all of them are, excepting the power pins, all of them are inputs for the NAND gate. And this is a NOT 7404. This is a NOT, and exactly like I did it in my circuit. And I think I made a couple of mistakes until this time. I really didn't understand how this functions, how this operates, and I did some mistakes. For sure I did some mistakes. I don't remember when and how, but I bet my ass I did some mistakes, because right now I tested for number 1 here, on the red LED, and I tested for, and it worked, and then I tested for number 2, and when I tested for number 2, I don't have here the circuit, I have it on my phone to show you exactly how they are, the connections they are there, but I was mistakenly numbering the wires, these ports, which, as you can see, or as you can know already, this is port A, then jumps to B here, C and D. But in my diagram there, I have numerated it with 1, 2, 3, 4, and I was automatically believing this is 1, 2, 3, and 4, and I was making this mistake without understanding why is not working this output, and I catch myself doing this mistake. And I realized, hopa, this is not 1, 2, 3, 4, like in the diagram that I was looking into. I have to think on this chip pins how everything is connected. So if here is a number 2, this wire here, I don't know, this is going to whatever there, to B is going to be. This is number 2 actually. So the number QA is number 1, number 2, 3, and 4, like that. Numbers of these wires, these connections, I mean, that are going there, and to the diodes. And I only made 3 options so far. I hope I will not get errors or anything funny, but so far it worked absolutely perfectly if I'm paying attention on the order of the wires that I'm putting here. And I've checked the voltages I'm getting here. I can show you actually. I hope I can show you. Also when I was probing with my oscilloscope, this last wire that is connected to any port, that is the output port that is there, this is not actually visible. This wire, this connection is not visible by the oscilloscope. I had to figure out this myself. Or let's say I'm setting it is already set to 8 like it is right now. Actually, I can show you. And if I'm putting the probe, absolutely 0. Now I'm getting it out, and there is a very slight bump, but absolutely infinitesimal, but staying on zero level. And I didn't understood this little detail, and it is very important detail. I didn't know this. Let's say I'm counting to 8, and I'm putting the black wire, this connection wire, on this output port here, port D output. I have to put my probe on the pins beneath this number. But if I'm putting it to 4, let's say I believe it's C, on port C here. If I'm putting it here, and if I'm putting my oscilloscope probe on D, it will still count 0, so it's over that number, you know. And I wasn't aware of these little details. I was thinking it is counting all the pins at once. I think it was like that. But if it's not reaching that that number, is my oscilloscope probe doesn't read it. So that's there are little details that are not evident. You know, you don't really get them. We can count together here. Let's see, 1, 2, 3, 4. And this is set on 4 here, and it is counting to 8. You can check this LED here is counting to 8. and also this guy here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Also, you can count the binary here. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is only leading on the fourth. 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And that red LED is leading on the number 4. But I have to make all these settings. Also invert and switch these diodes here. Sometimes, if you looked on my schematic, it's a bit hard to make all these connections. But it is working. This guy is not doing anything here. Also, the voltage is very, 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 very important, because this is why I throw away those diodes that I had there, because I wasn't getting any voltage at all. I was getting only 0 or very, very slight over the 0, And right now, let's see if I'm putting it somewhere. Let's see where I can put it. On 2 here, probably. Yeah, I'm looking also on the oscilloscope. I wasn't getting that with the diodes that I was having before. Also very, very important. Also another mistake that I did, because I'm not that used. I'm very, very sincere here. I have absolutely no reason to lie to anybody. But I'm not that an expert on using this fabulous oscilloscope that I have here. And this fabulous oscilloscope sometimes is getting stuck. If I don't change the timing, as you can see here, let's see. So it's right now it's set to 0.2 seconds, so 200 milliseconds. But if I'm not changing it down or up, it's remaining stuck on some reading. But immediately after, sometimes, not all the time, it's like a bug of this device or something. I don't know why, on how to repeat that to actually show you. But sometimes it's like that, is having a personality of its own. It's golden. It's golden oscilloscope, Hercules. So, but in the moment I'm switching up or down, it is showing me the actual reading. But until the moment if I'm not switching anything, it's not reading anything, which is very, very, very discouraging. Also, if it's the reading is too low, like a couple of microseconds or nanoseconds, microseconds, it is not showing me the up and down. It's showing me only one line, like it's too fast. The timing is too fast, and I have to slow it down the timing to actually see the rise and fall of the square waves. So there were multiple problems that I wasn't really used to them and accustomed to them, and I'm an artist after all. This is not my job, but I like doing it, and I like to learn, and I like to do stuff. That's the only reason that I'm doing everything that I'm doing, to do stuff, to do some interesting stuff, and most of all some helpful stuff, if possible. If not possible, well, it's a waste of time. But my goal is to make some useful stuff that especially me, and also you, because I'm putting everything that I make public. I make it public for everyone, and to actually use and to get some benefits from this stuff. Hopefully, unfortunately, I have a lot of stuff that is only knowledge and the experimentation and the stuff. But in the end, the final goal is to make something useful, and I have a plan for everything that I'm making here. But yeah, we will see later. So far, so good. Another very important thing: I didn't put the transistors. I linked directly these yellow wires to the ports of the chip, without additional transistors that I was originally planning to put MOSFETs or NPNs. Actually, I did a test here before I get this result here. But when I measure it, I got less voltage from that output of the transistor that I had than the voltage that I was getting from directly from this output ports. So here I get a clean 4 volts. I don't know if you can see it. Let's see. So it's set to 2 volts here. 1 square is 2 volts. So it's exactly, or less a little. It's not really 4. It's 3.9 maybe volts. But then adding another transistor, taking the wire to another transistor and I should have get 5 volts or close to 5 volts, but I didn't. With the NPN, with this guy, with the NPN, this is a BC change. Let me check it. 548, BC 548. You can see it, I suppose. And then with the MOSFET, where are the MOSFETs? I didn't. With ERFS 44N, I put. And the ERFS 44N, actually, I can show you. These guys pretty big, but I did a test a little bit. With the MOSFETs, I got 2 volts per output. And with NPN, I got 3.5-ish per output. A little bit less than the original output from here. And I should have get 5 volts. I suppose there is a drop, 0.6 volts for the NPNs. And I suppose also, from my general knowledge that I have, on the MOSFETs, I have to feed its gate with higher voltage to actually open correctly or fully. I'm not an expert. I know some stuff about transistors, but not everything. And especially when you have to build something with them, it's in reality everything is changing from the theory. As my mathematical friend should know already this stuff. Right, this is it. Happy, very, very happy news actually. I cannot change right now because there are a lot of permutations here. and I cannot change to show you that that is actually doing its job correctly. You have to trust my word. But in the future movies, and also I didn't, very important, I didn't test multiple when they are all linked to the same bus. Right now I'm testing only one single module here, and it's behaving okay. But when I will add all the other modules, we will see there how it will behave. I hope it will. In the future, I don't know if this will support, the output will support from this chip will support all of those all of that stuff that I have there. I will have, but it's only one LED lighting. You know, one LED is 10 millivolts, and yeah, I suppose. But there are a lot of voltages, dropping voltages on those diodes. I suppose. I don't know. We will see. We will see. I'm very curious how it will be with everything, you know. But this is the displaying. This part is the displaying, and this is the logic here. The displaying side of the circuit is complicated. It's way more complicated than I expected. And the only difference, good difference that I as an add-on right now is this 4 LEDs here that are directly on the output ports of this chip here, directly to it. And it's the upgrade from the last time when I had the diodes. I know you didn't see. I didn't film. I didn't make a movie with that circuit, but it didn't work. So I didn't feel the need to make a movie with it not working. I like stuff that is working, not that is not working. So yes, this is it. Pretty much this is counting perfectly. Right now it's counting perfectly. And also I can speed up the thing or slow it down. Very, very slow actually. As you can see, you will have to wait until everything will do anything. Or here, it's very, very extremely fast. This is the maximum when everything is so fast that it's staying almost, yeah. So it's a very good thing that I did here with the clock variable clock pulse frequency generator. Very, very good. And also the add-on or the upgrade here. You have 2 wires and another capacitor. I had to tweak it, and it's very extremely tweakable, which is good. The biggest problem that I will have to face is the connections of everything. When I will have to connect, especially these wires here, when I will have to connect everything and make a plug to switch from to count one number and then another number from 1 to 16. So that contactor that is making multiple contacts at the same time, probably only 4 contacts at once. Or there are some things, well, like that thing that I have here, the resistor. If you look closely, I have it on pin. No, it's not good. Like that, on minus. It should have been. It worked with plus as well for some reason. But usually it's on minus, and it's because if it's on plus, it's not counting once. If I'm counting to 1 or to 2. It's giving me an error if it's on plus. I was testing something, but this is the normal way of keeping it here, not to positive but to negative, and on R02 here, the 3rd pin. While in my simulator, I had to put it here to positive and it's giving me erroneous results. So this is inverse. And then on the 16th permutation, counting, if I want to count to 16, I have to link this pin to ground. So I have to take out this resistor to link it to ground and put it to the positive. I don't remember right now, but I did so many tests I can't remember everything. But there are more than 4 contacts that I have to deal with, including this thing to ground here. It will have more contactors, more than 4, probably 5 or 6 even. Depends when I will have to switch to what number to count. That will be very, very hard to do it when I will build the entire thing. But right now is in testing mode, what you are seeing here. And in testing mode is a go, is okay, is working, which is absolutely perfect. I'm very, very happy, and that's why I made the movie about it. Thank you very much. This is it, and I hope I will hear or read from you later. Bye bye, my friend from UK. Bye bye. Long live the Queen and the King of UK Imperium. Bye bye.